We are solving a question regarding equilibrium. The diagram shows the particles A, B, C hanging freely in equilibrium, each particle being attached to the ends of the string. The other end of the string, three strings are tied together and they are acting at the point X. The strings carries A and C passes over a smooth fixed pulley pegs at P1 and P2 respectively. The weights of this A, B, C are 5.5 Newton, 7.3 Newton, and W Newton respectively. The angle P1x P2 is the right angle triangle. Find the angle AP1x and the value of this W there. Since there are three particles at the point A, B, and C, at the point A, the weight of this one is 5.5 Newton. The weight at B is 7.3 Newton. And the weight at C is W Newton. And P1x P2, that angle is of 90 degree. Since the particle is in equilibrium, we know that here the tension is, let's say, T1, which is being balanced by the weight 1 of that object. Here the tension is T2, which is being balanced by the weight W Newton. And A P1 x P2 is x degree here. Now, if it is x degree, this is 90 degree angle. So we can resolve it into two components. Let's say this angle is theta and this angle is 90 minus theta. Then, since here is T1, so this also force is T1. Here is T2, then this force is also T2. So here we can write it as T1 and here we can write it as T2. Now, T1 is balanced by 5.5 Newton. T2 is balanced by W Newton. And now we will solve the forces into components at the point X there, where weight of this object is 7.3 Newton. So we can have this figure there. It is weight of this one is 7.3 Newton at the position B. This force is T1. This force is T2. This is making an angle of theta, and this is making an angle of 90 minus theta. But from the trigonometry, we know that sine of 90 minus theta is equal to cos theta, and cos of 90 minus theta is equal to sine theta. So these are the observations which we take from this trigonometric functions there. Now we will solve these forces into components. So here it would be the T1 sine theta, and this is component is T1 cos theta. Same, we can solve it for this component. It is T2 cos of 90 minus theta, and this component is T2 sine of 90 minus theta. So we know that cos of 90 minus theta is equal to sine theta, and sine of 90 minus theta is equal to what? Cos theta. So the forces here at the point, this is P1 and this is point P2. So we are going to solve these components into these forces. So it would be T1 is there 5.5 sine of theta there, and this component is T1 cos of theta there. Here is the weight W, sorry, 7.3. This force is T2 sin theta is becoming cos theta, and this component is T2 sin cos of 90 minus theta, that is equal to sin theta. So this is the components at this point there. Now we are going to resolve this one by horizontal components. This is 5.5 sin theta is equal to T2, which is equal to weight. So we can write it as equal to weight into cos theta. Let's say it is equation number 1. For this horizontal components, sorry, vertical components now. The two upward components is T1. T1 is 5.5 cos theta plus T2, which is W sin theta, and that thing is equal to 7.3 because this weight is at the point B there is 7.3 there. So let's say that is equation number 2. Now there are two variables W and theta there. So we are going to substitute one in terms of each other. So here W is equal to 5.5 sin theta over cos theta from equation number 1. Now we put into 2 there. So it should be equal to 5.5 cos theta plus W value is 5.5 sin theta over cos theta into sin theta, and that value is equal to 7.3. This is going to be equivalent to 5.5 cos theta plus 5.5 sin square theta over cos theta is equal to 7.3. Not take cos theta as an LCM. So it will become 5.5 cos square theta plus 5.5 sin square theta is equal to 7.3. This will become 5.5 cos square theta plus 5.5 sin square theta is equal to 7.3. But we know that if we take 5.5 as common, then sin square theta plus cos square theta is equal to what? 1. So 5.5 into cos square theta plus sin square theta is equal to 7.3 there. 7.3 cos theta. So this is equal to, we know that sin square theta plus cos square theta is equal to 1. So 5.5 is equal to 7.3 cos theta. Now cos theta will be equal to 5.5 over 7.3, or cos theta is equal to 0.754. Theta will be equal to cos inverse of 0.754, which is equal to 41.1, which is the angle between P1 x and P2. This is the angle theta is. Now, the other thing is going to be calculated for this value of this W there. So, W is equal to 5.5 tan theta for sin theta over cos theta is tan theta. So, this will become 5.5 into tan of 41.1, and that value is equal to 4.8. So, this is the value of W there. Since they are asking the angle AT1x angle, which is theta, because if it is theta, then alternate angles will give you this value of theta there. So that value of angle there is equal to 41.1. And the weight of this object is equal to W there, and that thing is equal to 4.8 Newton. So these are the two answers which are being required in this question there.